find all our derivatives. We have our power rule, which is another video, and then we also have something that we can't do the power rule with. So let's just say we got f of x is equal to e to the x. Now, instead of this being a power function, this is a exponential function, which means we need a different rule. So the simple one here is just this, just e to the x. And this one's pretty straightforward. It's just e to the x, right? So there are a few times in mathematics when we say, well, this is just simple. Well, this one is. We could do the definition of derivative on this one and come out with that. And that is not simple to use the definition of derivative on this. It takes a little bit of time. It's not trivial, but it's not terribly difficult either. But what about when it's something a little bit more difficult? Let's say we talk about g of x is equal to 3 to the x power. Well, what is that derivative? Again, we can go back and use the definition of derivative to do that. But it's a little bit easier if we say, well, what if there was an exponential rule? So here is the exponential rule. Okay, so we don't have to go back and use the definition of derivative to do exponents. So if we say that f of x is equal to a b to the n power, okay, then f prime would be ln of b times a times the derivative of n. I'm going to write it like that for a second. And then times b to the n. Okay? So what that means is over here with g prime is that we're going to do ln of the base. ln of 3. That's the first part. And then the a here, the a is actually understood to be a 1. So we would do 1 times the derivative of x, which is 1, and then times the original function, which is 3 to the x power. And that's our derivative. Now we can simplify that quite a bit. Normally we would write it ln of 3 times 3 to the x. Okay? Well, let's just do another example, because the exponential rule can be a little finicky sometimes to kind of grab a hold of and keep. So let's just say that h of x is equal to, let's put a 3 here, let's say 3, and then times 4 to the x squared power. So this is still an exponential, right? And this is actually kind of teetering into the next a couple sections away. So this is a difficult one here, but I think we can do this. So again, the rule says to do ln of the base, so that's ln of 4, right? And then times the leading coefficient, which is 3, times the derivative of the exponent. The exponent is x squared, and the derivative of x squared would be 2x. And then times the original function. Now we can again I can go through and prove why this is true using definition derivative, but that is a whole nother video, okay, whole nother lesson. But this is what you end up with. So we can then simplify this as 6x ln of 4 times 4 to the x squared power, right? And this actually sets us up to talk about why the derivative of e to the x is e to the x. So if we're using that same rule, right, and we're talking about e to the x, so let's just go back to that first one we were dealing with, which was e to the x, and we use that rule, f prime is going to be ln of the base, which is ln of e. Coefficient there is 1 times the derivative of the exponent, which the derivative of x is 1, times the original, which is e to the x. Now, what's ln of e? That's 1. So that's 1 times 1 times 1 times e to the x, which is just simply e to the x. All right? So you're really not memorizing 2 rules here. You're really just focusing in on getting 1 rule. And if you want to, you don't have to memorize this rule, but it does make life a little bit simpler to kind of commit it to memory and process it. All right?